is about sort and search. First, you need to sort the cards in the deck. So the algorithm that I'm using is quicksort. And yeah, so first I defined the comparison methods in the card class, and so that I can compare them directly in the quicksort compared to cards object. So the quicksort will call itself recursively and until the whole set is sorted. The second thing is to do the is sorted property. So it will go through the whole deck to check if all the cards is smaller or equal to the ones that is after it. If it is true, it means it's sorted, it will return a true, and if it's not, it means it's not sorted, it will return a false. The other thing is about find the specific card and return its location. So this will use the search method. First, it will call describe card method to get the specific card that we want to find, and then it will first check if the deck is already sorted. If it is, it will calculate the index directly from the card's suit name and the card's value. It will cost a constant time. If it's not, it will need to go through the card to find go through the cards in the deck one by one to find that specific card we want to find. This time complexity will be OM, so it will finally return the index as a result for the search method. And the other to do is here. So in this one, it will check if the deck is already sorted. If it is, it will return a sorted deck of 52 cards. If it is not, it will return a shuffled deck of 52 cards. So in the main method, it will first initiate the deck, which should be already sorted. So it should print out a sorted deck and then shuffle it. It should print out a shuffled deck. And this is another method that I defined to print out all the cards in the order in the deck. So that we can search for a specific one and check if the index that we get is correct. And the same with the sorted deck. And it should print out the sorted deck. We print the cards in order, and then we search for a specific one. And let's give it a run. So first is when it's initiated, it's a sorted deck, and when after it's shuffled, it's a shuffled deck. And this is the order of that shuffled deck. Let's say we want to find the queen of spades, which should be index 1. Spades and queen. So the card is at the index 1 of the deck, which should be correct. And this is then after the card is sorted, it's a sorted deck of the cards, and this is the order of those cards. And this time we want to find, let's say, 4 of diamonds. It should be at the index 3. So diamonds 4. The card is at the index 3 of the deck. So yeah, this should work. The second task is about trees. So in this one, we need to create the tree based on the number array in the CSV, and calculate out the number of leaves and the height of the tree. So in this task, first define the tree node class and also the tree class itself. The tree will initiate with its root and set the default values for the traversed height and the leaves these properties. And then a method called insert, this one will insert the certain values into that tree and create the node. The rule here is that if the value that we want to insert is smaller or equal to the value of a certain node, we will insert that value to its left. Otherwise, if it's larger than the value of the node, we will insert that into its right. And another method I defined here is called traverse. This one will traverse through the whole tree and calculate out the height and the leaves. It will traverse through the tree in breadth first order, and also it will set the traverse property to true so that we can know that the tree is already traversed. In the methods to get leaves and the height, they will first check if the tree is already traversed and the number of leaves and the height is already updated. If it is, it will return them directly. If the tree is not traversed already, they will call the traverse method and then return the leaves and the height. Here's another method to count the leaves, but it's in depth first order. So let's see what's in the main method, main function. This part we will deal with a CSV file and get the numbers into an array list and get it printed out. And then we're going to initiate that tree and insert all the numbers into the tree. And after the tree is created, we will print out the number of leaves and also the height of the tree. So let's give it a run. So here is the list of a number in the CSV file here. And we can see that the tree has 32 leaves and the tree has a height of 14. The number of leaves I got is not the same as professor you give here in this document. So that is why I made a second method to also count the number of leaves in a depth first order to double check it. But it seems that both of these two methods are giving me 32 as the number of leaves. So I'm thinking 32 would be my answer. Yeah, that's it.